What's the most important feature you're going to build on your website or app? It may just be search. Search is actually a multi-million-dollar feature for pretty much any company you can think of. Netflix, when you search for a movie, Amazon, when you search for product, any kind of e-commerce website actually. Think of any app or website you use often and you'll see that search is probably an important feature there. So let's actually talk about how we can do that on our own Next.js websites and apps. There are some things that you have to pay attention to, especially with the new Next.js app router. But there are also some search specific things you can do to make it actually really good. So as an example here, let's say we have a website about recipes. We have a bunch of recipes in our database and people can search here for them. So if people start typing here for pasta, they will already get some suggestions here below the input field. So we want to add autocomplete here, but also in the search results themselves. So if I actually search here and we are going to take a look at, and here I get a bunch of actual results. This is really important, but you can do this in various ways. So this is actually semantic search, and you can see that because fish, the word fish, well, it's part of this recipe, but it's not part of this recipe. So the word fish is not literally present in the description here. However, salmon is. And so the underlying algorithm here powering this understands that salmon and fish are semantically related. And so we still get that as part of the search results as well, and here as well. This used to be pretty difficult to do even a few years ago. However, thanks to AI and maybe you've heard of RAG and some other tools as well, this is much easier now. So that is semantic search. Now there's also something called fuzzy search, which basically allows the user to make a typo and it will still give them relevant results. So there's a bunch of search related things that we're going to take a look at. Now notice I also put the search query here in the URL. So I'm actually not using use state in React for this input field. I'm actually using the URL for state management. There are many benefits to this. So one of the benefits is that somebody can bookmark this. When they bookmark it and they come back later, they get the exact same URL. And because of that, they will get the exact same results that they were looking at before. Also, somebody can copy this and send it over to somebody else. Right? That person will also paste this exact URL and also will get the exact same results. So there are many benefits of tying the results, of tying the state basically to the URL. Still quite underrated in my view. So we need to know a little bit about search parameters and how to update them in Next.js as well. Also, how do you fetch these results in a server component, maybe using Suspense, because if I search for something else now, pasta, you can see we have a loading state for this as well. So there's a bunch of Next.js specific things we want to take a look at as well. Now, how are we going to power this search functionality here? What technologies are we going to use? So I already mentioned RAG, and RAG, it has to do with vectors. So typically you would need a vector store for that. So you would have to find some other database. Well, MongoDB, they are today's sponsor, allows you to store your vector embeddings right alongside your normal data. So you can use a MongoDB database both for your normal operations as well as for a lot of AI features. And we're mostly looking at search in this video, but they allow you to store those embeddings in your database right alongside with your other data actually, making RAG super easy. Now, I actually had a great time using MongoDB, by the way. I run an e-learning website. So I have all these students here. They can sign up for courses and then in the dashboard, they will go through courses. This is actually powered by MongoDB. I've been using it for the website for a couple years. I had a great time using them. So if you have to implement anything with vectors, make sure to check them out. But let's actually just try and take a look at this project here. I will leave a link in the description as well for the code. So if you want to take a look at it yourself, you can do that as well. All right, so where do we start? Well, I actually have a very simple Next.js app right here. I removed a bunch of things and this is the homepage, right? So we have recipe suggester. That is what we have here. And then we have some text below there. And then we have a form basically for the input here. And then below that, we want to have the results, right? So I have a div for that, which will display the results. That's all that we have here. Now, we already have the first decision to make because in Next.js, everything by default is a server component. I actually marked this as async, but we're not going to fetch directly in here. The search bar here is going to be quite interactive. So this needs to run in the browser, right? Because what we want to do here, especially with autocomplete, we need to hook into the user's click event, let's say. Right? That can only happen in the browser. So we need to make that a client component. I could make everything here a client component, right? But then everything else would be affected by that as well, even though only this piece needs it. So it's a better practice to refactor the piece that needs that interactivity into its own component. So I will remove it from here and I'm putting it into this search bar component, right? And again, it's just an input field here. We have an SVG for this icon here, and we have the actual input field right here and a bunch of styling, but this is all not that important, right? So it's just an input field with some styling, and I'm going to use that component here on the page, and I can mark that one as use client, right? Without affecting everything else here. This can stay a server component. Now we have the results list below there, and we're gonna fetch data for that. We may actually want to do it very close to there as well. So we may also want to put this in its own file. We could technically also fetch on the page here, and that would be perfectly fine. However, just out of clean code principles, we want to refactor this. So let's say we have some recipe list component for that. I'm just hard coding some recipes here just so we have something to look at and work at. So it's just an array with a bunch of recipes. This is how our data will look like. So we have some title and a description, okay? And we are just mapping over that here and basically just creating a link in their title and description and just a bunch of styling and markup. But in terms of data, that is how this is structured. So then we can include this on the page. Okay, I will import that here. Okay, so now we have this. I just hard-coded 3 recipes. So now what we want to do, maybe just to get started here, is if I search for pasta, let's say, I only want to see the recipe with pasta, right? If I search for chicken, we only want to see the recipes that have chicken in there, which is only this second one here, right? So how do we even start off with something simple like that? Well, I would argue let's actually start by putting this in the URL, reading from the URL, and retrieving from our data the specific recipe that's relevant for that, right? So before we even add a database, let's see how the flow here works with data in Next.js. So let's go to our search bar here. So when the user clicks on search here, we are submitting the form. That's the submit event on the form. We can hook into that. We can do on submit and we can say handle search. And we can define that function up here. So when the user submits the form, we will run this function. So initially we want to just prevent the default, because by default, when you submit a form in a browser, there's all sorts of things happening that we don't want. We want to control that submission. So we need to get the data, basically what the user wrote here. We need to get it out of that form. So we can take the event current target, which is the form. We can turn it into a so-called form data, which contains all the form data, but we just want to get whatever the user wrote in that input field, right? So that's this input element, and it has a particular name. I just call it something really explicit, input search value. That's what we can use to then get the actual value, whatever the user wrote, basically. What do we want to do with that? Well, we don't want to do it with use state in React. We actually want to just add it to the URL, right? So we're first going to write to the URL, and then we're going to read from the URL. But first we need to add something to the URL, and we're going to make it so-called search parameters, right? So we want to have something like Q, the query that the user has, and then chicken, right? This is called, if we would have multiple, by the way, it would look like this, right? And these are so-called search parameters, where you have a key and a value. Now in our case, we're just going to have 1. And to work with that, the browser gives us this new URL search params that we can use here, just to make it working with it a little bit easier. So we'll call it params. Now, if the user wrote something, so if there is actually, let's say, chicken in there, this will be truthy, right? This will be truthy. Chicken is truthy. And we can then set it, the Q, to chicken, right? So then we can say Q is chicken. Now, if it's not truthy, for example, maybe because the user actually removed it again, right? So remove them and then search again. In that case, we actually also want to clean up our URL and remove the Q. And then we're actually going to use the Next.js router to actually update the URL. So we can use the user router hook actually, which allows us to do router.replace, basically replace the current URL with a new one. Now we want to have the complete URL, so we also need to add everything before the search params. So in this case, localhost, blah, blah, blah. We can get that with the path name. This is another hook that we can use in Next.js in client components, right? So now we can construct the entire new URL, and we can actually take the params. We can do it to string, so it will actually be a suitable string for a URL. You want to pay attention to the URL, by the way, when you have like characters that need special encoding, or you have spaces and so on. So this should take care of that. And actually a use router, we need to import that from Next navigation, so not from Next router. Cool. So now if we have all of this, let's try it out. If I now type chicken and I actually submit the form, you can see we have now Q is chicken in the URL. Okay, so this is writing to the URL. I can now share it with other people. I can bookmark it. And when somebody else comes here, we want to show the same search results. So we do need to make sure the search results are actually relevant for this, for whatever is the search parameter value here. So of course, in this case, we only want to show this chicken one. So we are now in the search bar, but this is the list of results, right? So we need to go to the recipe list here. And this one needs to know what the query is. How does it get access to that? We could use searchParams, but this only works in a client component. So we would have to turn this into a client component. And typically we do want to allow things to stay on the server side if that's possible. Let's try keeping this a server component. How can it then be aware of whatever is in the URL? Well, we can actually get the search parameters from a page component itself as well. And we can then pass it as a prop. So we can take search params here. So we can actually get it like this. So in the Next.js page components, you will actually have a search params prop. In the more recent Next.js, it's actually a promise. So we have to do a bit of an awkward await, and then we can get the actual value like this .q. So then we have the actual query that the user wrote. We can also just call it query actually. And that's what I can then pass to the recipe list as a prop. Of course, I could also use it here and fetch the data directly from here if I want, but maybe I do want to have everything nicely confined to that component. So I can just pass it as a prop and it will receive it right here. Okay, so then we can take the query and now we have our recipes. I moved it out of here and actually moved it as a variable here. We have 3 recipes. They each have a title and description. So we need to take whatever the user was searching for. If it's just an empty, right, if the user actually removed it, we just want to show all the recipes. But if the user did write something like chicken, for example, we want to go over each recipe and we'll just check, is there a chicken, literally chicken? The complete word chicken in the title? Is it maybe in the description, right? So very, very bare bones, do it yourself search. But you can see now chicken is in the URL and we do get chicken here, right? If I actually search for pasta, if I search for this, you can see I get the other one. If I actually remove it and submit, I get all of them. If I search for Greek and press enter, I get this. So now if I share this with somebody else, or I bookmark this and I come back to this later, I would still get the Greek recipe that was on my mind and that I wanted to come back to. Now, by the way, notice that my search bar is not pre-filled with whatever is in the URL. So let's go to our search bar. Here I can use search params because it was already a client component, so I might as well just use that. And I can get whatever was in the URL like this, right? And then I can use that as the default value for the input, right? So I can say default value, make that whatever was already in the URL. So now if I go back here and I maybe bookmark this, now I come back, you can see Greek has already been added here to the input field as well, right? So I think this is a very basic example of how you can work with search parameters in Next.js. Really important for pretty much any application that you understand this flow. Now we'll add some actual search in a second. Now realistically it will take some time, right? So here it's all super fast, right? So pasta is instant because I just hard-coded some recipes right here, so it's all super fast. Realistically, when we are actually going to search and reach out to a database, it may take some time. So let me actually just add a 1 second delay here just to simulate that a little bit. Because right now if I search for chicken again, if I press enter here, I don't see any feedback. It takes a second and then I see a result. But in the meantime, if I now click on search, I'm waiting and only after a second I see something. So we need loading states to signal to the user that there is something ongoing and that everything is all right. Nice thing about doing your data fetch, well in this case, We're not data fetching yet, but we'll do that in a second. Reaching out to a database. If you do it in a component like this, wrap that in a suspense in Next.js. So I can do suspense. I can move that in here. And here I can specify a fallback. And here I can use a fallback, which I can basically use as a loading state here. While this component is suspended, basically as we're sort of waiting for it to finish up, it will show this paragraph here. I could separate it out in a separate component, but this is a nice and quick way to add a loading state while we're getting the results from the search. So now if I search here for chicken, right, so if I press enter here, we actually don't see it. Why do we not see it? It's a bit strange with how the suspense works, but if I refresh, you can see this actually works, right? So initially, when you refresh the page, it works, but then if you search again, if I tap pasta now, nothing happens. Well, this is because the suspense only runs once initially, and it needs to be re-triggered again to run again. We can do that with the key prop actually. So with key in React, you're basically telling React that this is unique. So if the query changes, it knows it's new and it will re-trigger it actually. This is actually very tricky, so don't worry if you're confused. But now if I do that and I type chicken, I actually get a nice loading state here as well as when I type pasta again. But now everything here works. Okay. Now, by the way, in the Next.js documentation, they also recommend that if you use searchParams in your component, that you also wrap that in a suspense. Don't worry if you're a little bit confused about all this new Next.js stuff. That's totally normal. All right, so right now, of course, we just hard-coded a little bit of data here. Now we actually want to add a database and we want to make it work with an actual database. And we don't want to have our own concoction here of search algorithms. So I'm going to remove that. We'll just hard-code an empty array there. Let me actually also remove the simulated sleeping function there. And I will also remove the hard-coded recipes from here. Okay, so now we have no data hard-coded in our app. Now I need to have a database. So I already signed up for MongoDB. You can get started for free and you can find a link in the description. So MongoDB makes it super easy to do a bunch of sophisticated search actually. Especially vector search is really valuable because you get great results with very little effort actually. So if you have a new account, we can create a free cluster here. So I can create a cluster and there is a free option here. And I will just go with all the default settings. It will basically provision the resources for my database. All right, so here we also need to connect to our database and we can set some things up like the admin user. Yeah, so we can connect to MongoDB by using the Node.js driver. However, we typically use an ORM in our applications. So I will actually use Prisma, but you can also try this. MongoDB, by the way, also has Compass, which is a GUI. I use this myself for my e-learning website. It's just an app on your computer and you can visually interact with your data. It's really nice. They actually also have a VS Code extension, which allows you to inspect your data here as well, by the way. But we will actually just go with Prisma. So I will actually just close out of here for now. If you are creating a cluster for the first time, it may actually ask you for creating a user and a password. You need those credentials to actually connect to your database. So make sure you store your password somewhere. Don't show it to other people. And by default, they may actually add some sample data to our database. Let's actually browse collections here. So if you're coming from the world of SQL, collections are very similar to tables in a SQL database, right? So MongoDB is NoSQL and we don't have tables, we have collections. And an item here, so here we have some sample data in our database. Let's say a movie, for example. And so a movie, this is called a document, right? So in SQL, you have a row of data. Here we have a document. Now this is nice, but we don't want to have this data. So I will actually remove this. Okay, we'll drop it. It may take a second or so. I'll just fast forward. All right, so now I have a clean slate here and I'm gonna create a database here. So we will add our own data. I will call this my-db, collection name, recipes, and create. Okay, so now we have one database and in there we have one collection. I want to seed this now with a bunch of recipes. How can I do that? Well, let's actually start using Prisma. Prisma makes it really easy for us to interact with our database. So I will stop the app. I will install Prisma as a dev dependency, and I will also install the Prisma client. Prisma has detailed instructions on how to set them up, on how to set it up with MongoDB on their website, but it's pretty easy. So I will run npx prisma init, and I will initialize it with MongoDB as the data source provider. Okay, so we get a Prisma folder now with a schema file. Now, since the latest version in Prisma, I'm getting this output here. Prisma is changing how the client is generated or where it's located. However, for now, I will remove this because we don't need that for now. So Prisma will connect to our database, but it needs to know the URL, the connection string. So it has created a .env file for us. And now we need to get a connection string for MongoDB. Okay, so let's take a look here. So how do we get it here? Well, if we go to data services here, if you scroll down a little bit, you will see here connection string. Okay, if we click on that, we get the same view as before. Here we see some options here. So let's actually copy the one here from the driver here. If I copy this and paste that in here, what do we see here? Yeah, so here you need to use your username and the password that you set up for your user. That's what you saw. If you create a new account and you set up your cluster for the first time, you may have done that. If you haven't done it yet, you can set up an admin user in the dashboard. Now I created some dummy account, actually just calling it admin and admin, just admin as username and then admin as password. Make sure you pick a better one and make sure you don't show it to anyone else. All right, now importantly, after the / here, I do need to specify the name of my database. So I called it my-db. So now we can go to the schema of Prisma and we can model our data here. So what we can do here is we want to have recipes in our database. How are they shaped? Well, they should have an ID, and actually with MongoDB under the hood, they have an underscore ID. It's going to be a so-called object ID. This is something specific to MongoDB. So we need to map that here with Prisma. Each recipe will have a title and description. I'm also adding embeddings here. We'll talk about it in a second. This allows us to get really high quality semantic search results. And we do it with so-called vector embeddings. And with MongoDB, we can store that directly with the rest of the recipe data. It's really nice actually. We don't need a separate vector store. And we have some standard created at and updated at field. Now we can just make this so that the collection name that will be created from this will actually be lowercase and plural recipe. So this is just what I wrote for Prisma, but my actual database is not updated with this yet. So what I can do now is I can say npx prisma db push, and Prisma will try to connect, and you can see it tried to connect and it says my database was already in sync. Maybe it's because I was preparing the video, but let's actually go to our collections here. Oh, it's actually just because I already created a database and that collection here in the UI. So now we actually want to add some data. Let's actually create a seed.ts file here. So here actually I will use the Prisma client, and I have a bunch of recipes here, right? So I have a lot of recipes here which I want to insert into my database. So we will just run this file once. We're just going to delete the previous files, right? This is all dummy data. Don't connect to your production database. This is just going to be for development purposes. And then we're going to insert them into a database by batch. So we're not doing everything all at once. We're doing Prisma.recipe.create. Very straightforward. Basically, it will allow us to insert all of this into our database. Now I just need to run the file. I can actually run it from the terminal myself with TS Node. I've installed it globally, and it's sitting in my Prisma folder, and it's called seed.ts. Let's try this out. All right, so it's starting to seed, and now it's seeding into my database. Okay, this looks good, and it's finished. Okay. So let's actually go here and refresh and see if that went all right. All right, so now you can see I have a bunch of data here in my database. So let's actually go back to our app here. If I search pasta right now, how can we make sure we actually get the data here from our MongoDB database here in our Next.js app? Well, if we go back to our component that was previously that is displaying the results. Here we get that query. So here from here onwards, we know what the user is looking for. We just need to make sure that we get it from our database, and then we'll render it out here. So how can we do that? All right, so I'm initializing the Prisma client like this. It is from the documentation. I have other videos with Prisma. I put it in a folder called lib, and the file is called db.ts. It basically just makes sure that the Prisma client isn't instantiated over and over again in a Next.js app. Well, we can use the Prisma ORM. We can say, hey, we want to use the recipe collection. We want to get all the recipes where the description contains the query, so pasta, for example. And we're not going to pay attention to the casing. So capital case, lowercase, doesn't matter. So then we get a bunch of results, and we can just map over that here. So very simple option, actually. Let's try it out. So if I now search for pasta, I do need to start my app again. And then let's actually refresh here and let's see what we get. Loading recipes, and I get a bunch of data here this time actually coming from my database, right? And if I search for salmon, let's try salmon, we get some other results here. If I search for chicken, I get some other results. Okay, nice. So what we have now kind of works, but the search is still a little bit too rigid. So if I search, for example, for chicken fries, right? So maybe I want chicken and fries, right? But, or maybe I'm just thinking of fries, but I meant fry, right? If right, there's chicken in here, so you would expect to see chicken if I search for this. But if I search for now, you can see it actually doesn't show me anything. And it's because the chicken fries, there's no description that has chicken fries in there. If I search for beef, I will get beef tacos and classic beef stroganoff. But if I search for beef grilled, perhaps, I don't see anything. Even though I think it would still be nice to show these beef recipes for that as well. So can we make an improvement? And the answer is yes. So we can use MongoDB, we can self-deploy MongoDB, or we can let MongoDB, the company, take care of that, manage all of that. And one of the benefits of that is that we get more powerful search capability. So we can create a so-called search index on our data. So we've already added our data. Now we can add an index. We can add a vector search index. So if we're building a RAG application, we can create vector embeddings. I'll show that in a second. There's also a simpler search index. Let's actually start there very quickly. So this will be, I will just call it default. And then I want to create a search here for my recipes collection, and I don't need to change anything else, so I will just leave everything as the default here. So it's actually super powerful. So if you know all about this, Lucene and other options, if you want to dig into that, you can do it right here. However, we will just go with the default options for now. Okay, and then it's going to build out an index, a search index, which will basically improve our results in a second. Okay, so our index is ready now. How can we now use it in our code? We are using the Prisma ORM, and this was still a relatively simple query. So we can use find many, basically get all of the Prisma features in here. However, for a more complex query, this may not always be possible. So for example, here we are going to run a raw command. So very similar to using the Node.js driver actually. But now with MongoDB, we're going to do a so-called aggregate. So we're going to combine a bunch of data from our collection. We're going to sort of run it through a pipeline. So first we're going to search all the recipes. We're going to use that index that we just created. That's the name that we gave it, default. We give it the query from the user and we say, look in the title and description fields for that query. We will limit the results to 10, and in the results, we want to have their title, description, and their score. So basically how relevant it was for the query here. Okay, and we can get the results like this. Let's actually try this out. So previously we were looking at chicken. We have this chicken stir fry as part of our recipe. Now remember when I said chicken fries, it actually disappeared. However, now if I search here, all of these chicken recipes still remain here, right? Including this one. And now it's actually sorted, which is for the one that's most relevant, right? Which is what I want, right? So previously we were getting nothing, no results for chicken fries, because technically fries was not part of something. However, it still has chicken in there. And so we now with this index, we have full text search, which is what we get with MongoDB Atlas, right? So that's much better, but can we make it even better? So if I say chicken, of course I will get all of them. But what if I make a typo and I forget the I, so I have chicken. So now all of a sudden I don't get anything. So can we make that a little bit better perhaps? And yes, we can allow fuzzy search. So the user can have some typos or other mistakes. There could be some small mishaps in the exact spelling and we would still get the expected results. So I can actually add that here. I can say fuzzy. I can allow up to 2 typos, but typically it is recommended that the first character needs to match, or maybe even the first 2, because otherwise you get a very wide-ranging results. Okay, but now if I try this chicken again, you can see I still get all of these chicken recipes. In fact, if I make another mistake, so I also forget the E, so now CHCKN, and now I still get chicken. But if I remove the last character, well, it actually still found one particular match, but if I even remove that one, no, chocolate chip cookies is still there. But you can see this is already much more powerful than what we had before. Now, can we make it better? Well, yes. If we have fish, for example, right now we get fish tacos here at the top. Okay, that's reasonable. But then we get a bunch of other things here that don't really have anything to do with fish, right? So we finally have this salmon one here, but it's all the way at the bottom here. Semantically speaking, it's not really good right now. So the search that we have right now is still very focused around the literal characters, the literal words. But of course, we just want to allow the users to write whatever's on their mind, and we want to semantically give them the right results. Right? So I even want to allow them to say something like, I want to eat fish today. Right? So of course, this is not literally going to be in some description. Right? So we need to look at the semantic meaning of the search query and compare that with the recipes. So can we do that? Well, yes, actually, it's very easy. So MongoDB has built-in vector search, which allows us add that semantic search capability pretty easily. And the way we can do it is by creating so-called vector embedding. So basically, if we go to our recipes here, for each of these documents here, I'm going to add another field called embeddings, which is basically just mathematical representation of, well, we're just going to do it for the description in this case. And then when the user has a query like this, we're also going to create an embedding for that, like a mathematical representation. And we're going to compare that with the embeddings in our database. And the closest ones are going to be at the top. So we need to create embeddings for the data in the database. So I'm going to use OpenAI for that. You need a so-called embeddings model, and they have a pretty popular one. So I'm just going to have a file here, and I'm gonna set up OpenAI as well as Prisma. I have a function here. I can pass in a text, and it will reach out to OpenAI to create embeddings for that particular piece of text using the text embedding 3 small model. Right? And this function just gets the embeddings and returns it. Right? It's just a utility function. Now I want to do that for every document in my database, for every recipe. So we're going to find all the recipes from our database, and we're going to do it in a batch again. But eventually we're going to do it for every recipe. Right, so we're just going to do it for the description, by the way. So we call that function I just showed you. We get the embeddings, and that's what we then add to that particular document, right alongside the other data. That's the benefit of using MongoDB. You get this out of the box. So that's basically it. Okay, so let me actually run that file. Generate embeddings.ts. All right, let's see what happens. All right, so now it's going to go through all of the recipes and create embeddings for them. It's really fast, so it's just a couple seconds. And it will then also immediately update our database. Right, so that's actually, we can probably already see it. If I just refresh here, we may already see a few with the embeddings. Yeah, so here you can see the first one here has a new field here, embeddings. And it's an array with a bunch of numbers basically, and the dimensions here are typically the length. All right, so then it is finished. So now I have my embeddings here in my data. Now I can create another Atlas search index. So previously we had like the standard one. Now we can create another one, but this time it's going to be a vector search for semantic search and AI apps. Cool. So now I want to use my recipes again, and I can set up configuration, but that's not necessary. However, we do need to specify which field has the embeddings. Well, it has already detected that, which is the embeddings field. The number of dimensions, which basically the length of the array. It's going to compare the mathematical representation of the user's query with the embeddings in our database. And there are several mathematical approaches to that. You can pick the one you want. I actually got great results with Euclidean as well. So I will actually just leave everything here in the default settings, and I will create the index. Okay, so it's going to build the index again. All right, so after a couple seconds, this one is finished. So how do we actually use it now? Well, if we go back here, so previously we were doing this raw command with fuzzy search, basically using the search index that we created. All right, so now here in recipe list, when the user has a query, we have an incoming query. We also need to create embeddings for that, so we can compare it with the embeddings in the database, right? So we do need to make another call to OpenAI for that. And then we can go through the pipeline again. So this time it's going to be a vector search. We need to give it the name, is the one right here. Where are the embeddings in the data? Well, it's in the embeddings field. We have the query embedding, and then we have some other parameters, but eventually we will get some results here again. Let's make sure we try that out. If I search for I want to eat fish, so let's actually run the app again. If I say I want to eat fish today, the actual fish recipe here, literally fish in the description, But I also get these other recipes that are indeed related to fish that do not have literally fish in the description. In fact, they don't have this entire thing in the description at all. But we get highly relevant suggestions here. And also importantly, we do not get irrelevant suggestions. So previously when we searched for fish, we also got a bunch of beef recipes and other ones. But now we get some really high quality result, and it's literally just a few minutes. So yeah, really, really slick. Right, so the user can expressive in what they want. Thanksgiving main meal. And yeah, we get some really good ones actually, like pumpkin soup. That makes total sense for stuffed acorn. Okay, I think that makes total sense actually. Right, let's actually try Halloween. I want something for Halloween. I get pumpkin. Yeah, that makes total sense. Gingerbread, I think makes sense. So yeah, I think this is a really powerful search. We can also combine this with some kind of keyword search, like a hybrid search, also possible with MongoDB. So yeah, really powerful search, right? So really slick. Now one other thing we also wanted to add here is some kind of autocomplete. So as I type HALLO, we get some suggestion perhaps, or maybe we do want to make that very specific for the titles of the recipes. So if I type something like pumpkin, that it would already suggest pumpkin soup, for example. How can we do that? Well, this is a little bit more complicated because now we're going to add something here to the DOM. And when I click away, it needs to be closed. When I type here, it needs to update automatically. It needs to fetch data as I'm typing. All right, so I got it almost to work. So basically we now have this box below the search bar. So if we take a look at the search bar here, and here below I have that autocomplete box. So it's just a component. Yeah, it's just displaying a list of suggestions, which are just the titles of the recipes. And this is mostly UI, it doesn't really have logic. So all of the logic is somewhere higher up, right? So here the suggestions is getting that from here. So how do we get those suggestions in the first place? Well, that's what we get here. So we do fetch the suggestions here. We do it based on whatever the user wrote, the search term, but we're going to debounce that so that we're not, if the user is very quickly typing something, we're firing off an almost unlimited amount of network requests. Right, so we're going to debounce that. So we actually keep track of the user's input value directly in the input field, but we run it through a use debounce hook that we created. And so we get a debounced version from that. That's basically what we're doing here. So then whenever that one is changing, we're going to run all of this. We're going to set loading as true. And here we fetch the actual suggestions, right? So we will actually create our own API endpoint, which I created here. And this one will get the query and will make the actual call to our database. Now here we actually have an autocomplete option here with MongoDB. And so eventually we will get back a response and we can set that as the suggestions. That is basically in a nutshell how it works. I need to manually enable the autocomplete feature. So if I go back to my normal index here, edit with visual editor, sure. And here under field mappings, I can set customized configuration. So here I can make title a data type of autocomplete. And there are many other settings, but this is the only thing I have to do here. And then I save here and it's going to rebuild the index one more time. All right, so then it is finished. So now if I try this again, let me just refresh here. Now if I try searching for pasta, you can see I get a bunch of suggestions here, right? And if I click on them, they also load here and it will actually search for that using the semantic search again, right? So yeah, I think this is pretty slick. Yeah, so overall, I think you can see how powerful this relatively easy these days. If you wanted to do something like this a couple years ago, it would be so much work. But now with this vector search, for example, yeah, search can be just really good actually. In combination with all the latest Next.js features, server components, and also storing it in state, I think this is a really powerful stack for building search functionalities. I want to thank you for watching and I want to thank MongoDB for sponsoring the video. Check them out. You can find a link in the description and I will see you in the next one. Bye.